So welcome, thanks for having me. My name is Blake Nancarrow and I'm your tour guide for this evening. We're gonna fly around the solar system and then go beyond. So please fasten your seat belts and place your tray tables in their upright locked position. This presentation covers about 5 weeks of time. So I'm going from today into about the first week of October 9th, I think, is our next Recreational Astronomy Night meeting. As usual, I've made a number of materials available. I have a calendar that shows icons and various things on various days. That's something that you can download. It's a PDF file. You can print that or put it in your smartphone or mobile device, stick it on the fridge if you want. I also have observing lists available in a couple of different formats. That includes Sky Tools, the Planning Tool, and Sky Safari. And for those that don't have those but still want some sort of computer list, I've made it available in Excel format. This is all these materials are available in the article that accompanies this presentation. In fact, if you go to our website right now, if you wanted to sort of follow along, all the text is there. You could go into our website and search for the Sky This Month 2019 and see the information for this presentation. I also have a QR code at the end of the presentation that you can scan if you prefer to use that. This is not our sun. The sun has been this sort of featureless orange ball for quite some time if you're looking at it through a tinted full spectrum solar filter. It was mentioned a couple of weeks ago, I think, by Frank Dempsey that we're in a weak solar minimum phase right now. The sun goes through a cycle every 7 to 11 years, and we're in a trough right now. So very little activity from the sun, at least in terms of sunspots and things like that. If you look at the sun through hydrogen alpha, maybe you'll see a few prominences, but again, not very spectacular. That said, I think on the Labor Day weekend, lots of people were seeing aurora, so there are still some interactions going on between the sun and the Earth. On the Labor Day weekend, again, some people got some photos of that up in the Halliburtons and the Blue Mountains and stuff like that. The sun enters, or is currently in Leo, and it enters Virgo on the 17th of September. There's lots of tools and resources that I use to do planning. One of the ones that you may be interested in is calsky.com, and for me, I've configured it to issue email alerts, so I get alerts about aurora and special ISS flyovers and stuff like that. So that's a good website to check out. There's the numbers that you may be interested in, particularly twilight times if you're looking for really dark skies. But if you look at the sunset and the sunrise times for now, today, and the end of this period for my presentation, October 9th, you'll see how the sun is setting earlier and rising later. So obviously we're getting longer nights. If you look at the night hours at the end, that's the calculation from sunset to sunrise. You can see that right now we're getting 11.2 hours of nighttime. But by the end of the 5 weeks, we're at 12.6. So what's happened in between? What's the special event that's going on? Do you know? Equinox, right? So equinox, where the day and the night times are equal, that happens on September 23rd, and that's all due to the axial tilt or the inclination of the Earth against the plane of the solar system. So if you're a big fan of summer, this is maybe not good news. I'm not a big fan of winter, but I do enjoy the longer nights. So you can start observing earlier. You don't have to stay up as late, or if you're an imager, you can just get a lot more photons in dark conditions. So you can enjoy that. Speaking of dark or the interplay of light and dark, this is an interesting example of the chiaroscuro effect, the interplay between light and dark here. Actually, in astronomy, we get to see this and observe this a lot, whether through our telescope or through our binoculars or just with our eyes, or when we look at images produced by space probes that are orbiting a distant asteroid or something like that. We can see this interesting effect of light and dark and the transition between that. Some people call that the clair-obscur effect, and it's most notable when you look at the moon, say at first quarter, at third quarter, you can see a lot of detail. It's extraordinary, actually, when you look at the moon at around first quarter, you can see how deep the craters are and how tall the walls are around that crater, and you can see mountain ranges, or you can see things in the Meridian that appear billiard ball smooth, but when you get steep lighting angles, you can see there's lava flows and fault lines and things like that. So again, the moon's pretty interesting when you've got these steep light angles. By the way, your main phases for the moon, September 14th, coming up in a few days, it's the full moon. That's when the Dunlap Institute big planet gazing star party is happening. So if people are looking at the moon there, they won't see any shadows, but they should be able to see some colors, maybe the different colors in the floor of a crater, or see the very brilliant ray patterns from some large impacts. The third quarter is happening on the 21st of September. If you're interested in the new moon, that's on the 29th. And then back to first quarter on October 4th. One day after first quarter, we have an opportunity to see lunar X. Do you see it? Do you see it? It's very small. See the little X pattern right there? Tanya captured the lunar X here some time ago, and that's an interesting, again, sort of interplay of certain craters that are sort of sticking up still in the sunlight, but the bottom of the crater or the other side of the crater is in complete darkness. So you get this X pattern floating in darkness. It's quite stark when you see it, but it's very small. You're going to need some magnification to be able to see that. That's west of the Mare Nectaris, just off to for our image there, it's just off to the right there. There's the Mare Nectaris, if you're looking for that. Also on October 5th, the planet Saturn is very close. It's about a degree away, so there's an opportunity to sort of do 2 for 1 at low power if you're looking at using binoculars. A couple of other notable things for the moon. There's a harvest moon on the 13th, just before the full moon. The new moon that happens is big. That's not getting any headlines. The moon is close to the Earth on that occasion. And the full moon that's happening on the 14th is super small. It's the smallest moon for the year. Is that getting any headlines? No. So it's the what should we call it, Chris? You in your skylights you refer to it as the puny moon. Puny moon. So maybe that'll get some traction. But of course, the moon has been doing this for millions of years, that it's in a non-circular orbit around the Earth. Sometimes it's close, sometimes it's far away, sometimes it coincides with a full moon or a new moon. That just happens. So I have funny feelings about these big sort of articles, all the hoopla in the press, but yeah, but it is what it is. The moon next week is very near the Pleiades and the Hyades star clusters, and that's sort of neat. If you look through binoculars or a lower power telescope, you can see lots of stars and then the moon going past those. So that's something to check out. So if we fly in our spaceship now out into the solar system a little bit, we're not too far from Earth. I'm going to do a little doodle here to show you sort of some things going on. Do you see the Earth right there? And I don't know if you can see that little gray dot in front of the Earth. That's the moon. This is right now, today. This is the way it would look if you were in space. And you can see the sun is in the foreground or ahead of the Earth. And then we have some planets there. So if you're trying to see Mercury and Venus and Mars right now, good luck. They're really sort of blocked, if you will, or lost in the glare of the sun. If we were to draw a perfectly straight line through the Earth and the sun, and you have planets that are on that line, in that alignment, that's called a conjunction. When you get the inner planets, in particular Mercury and Venus, going here, sort of between the Earth and the sun, that's an inferior conjunction, versus on the far side of the sun, that's a superior. So you can see, I hope you can sort of make it out here, that Venus and Mercury are on the far side of the sun. So they're sort of near where superior conjunction would happen. I remind you that in general, all of the planets and the moons in the solar system are moving counterclockwise, if you're looking at it from the top or the North Pole, if you will. So all these planets are swinging around this way in relation to the sun. I also remind you that the innermost planets move faster, the outer planets move slower there. So Mercury and Venus are moving super, super fast right now, Mercury in particular. So in a few days, Mercury is sort of going kind of this direction. It's moving or becoming visible in the evening sky. So if you're hunting for Mercury, that's promising, but it's at a very low angle this time. So it's going to be quite challenging, I think, to see that. Venus is going to be in our nighttime sky for many months, probably out into November and December and so on. So you'll be able to see that. Anything to the left of the sun, those are our nighttime planets. That line that I drew before, if I try to do it fairly accurately here, you can see Mars a little bit to the right of that line. Mars went through superior conjunction just a short time ago, last week. So that means it's becoming a morning planet. It's going to show up in the morning sky. So you might get excited about that, but if you think about it, Mars is on the opposite side of the sun. That's as far away as it can get. So if you're looking for Mars, even though at the end of this time period, in the first week of October, it's going to be about 13 degrees away from the sun to the right. It's going to be really hard to see because it's faint. It's far away. So these inner planets and Mars, not a great time to look at these right now. Let's turn the other way in the solar system. Oh, before I forget, Mars is having its own sort of thing with respect to its axial tilt. Mars is having a solstice on October 8th. Spot quiz. Do you know what the axial tilt is for the Earth? It's around 23 degrees. It's 23.4, I think. Do you know what Mars's is? It's 25.2. So they're very, very similar, these two planets. So they have seasons. We have seasons, and Mars has seasons as well. So it's having a solstice right now. All right, here we go the other way in the solar system. Now you can see I've just flipped around. We're looking the other direction. Mars is in the foreground now. On this occasion. But if you're here on the Earth and you're looking out at midnight, this is sort of your view. This is your window, as it were. So you can see Jupiter is way off to the right there. It's setting fairly early in the evening. Saturn not far behind. And you can see Uranus way over on the other side there. That's a late night object or a super early morning object, and it's going to get better and better through the next few weeks or months. But do you see what's interesting about Neptune? Yeah, it's pretty well directly opposite us. If you do some math here, you do some lines or angles, you draw a line straight through the sun, through the Earth, extend that out into space. Planets that pass or move through that line, that's described as opposition. Earlier this summer, Jupiter and Saturn went through their opposition sort of phases or modes, but you can see Neptune is very near opposition. In fact, it happened yesterday. And when planets are at oppositions, they are as close to the Earth as they can get. So that means it's a good time to look at surface features on a particular planet. It's a good time to see detail in the rings of Saturn. It's a good time to try and spot moons for planets. So neat stuff going on here. Those are all the gas giants on display in our evenings right now. So that's kind of cool. A little fun fact here, it was Gale that discovered Neptune back in 1846, but that was sort of the anniversary's coming up. That's September 23rd. Back to just a regular terrestrial view, here we go. That's the view sort of, again, from this evening, a little bit later tonight if it was clear, and you can see Jupiter way off to the right. It's sort of neat. It's quite stark, the alignment. I've flattened that a bit. There's some curvature there, but you can see that all the gas giants are nicely lined up there. And again, that's today, so the moon has got center seat in that. If you're trying to look for Neptune, which you can't see naked eye, it's a little bit too dim for that, you can use that little star where I've drawn the arrow. That's Phi Aquarii. So if you slew to that particular star, or you star hop to that particular star, you'll see a little blue dot beside that in your telescope. Jupiter's between Ophiuchus and Scorpius right now. You can see Saturn's just above the teapot of Sagittarius. You can see the circlet and that little triad pattern there. That's Pisces and Aquarius. That Neptune is just sort of between. And Uranus, you can't make out the stars there, but it's in Aries right now. In my calendar that I provided, that again you can download if you want, you'll see that on various days through the next few weeks, I've noted Jupiter events, or maybe I'll highlight a particular object like Europa or something like that. But a lot of times I use the phrase Jupiter events, and what that is referring to is that there's some interesting stuff going on. Usually two things happening at the same time on Jupiter. Like maybe the Great Red Spot is transiting, is visible, and maybe there's a moon transiting at the same time. Or maybe there's a moon transit and a moon shadow happening at the same time. I wanted to draw attention to an event that's happening on the 28th here, and I don't know if you can make it out. If you look closely there at the bottom, again, I'm going to do some little doodles here, but if you look closely at the time, you can see it's just like a few seconds or 1 second before 9:01 p.m. There might be subtle variances in the time depending on your location, but this is a simulated view from the Stellarium software for the Toronto location. So 9:01 basically are just a second before that. And you can see if you're looking at Jupiter, if you're settled and relaxed and focused and so on, you'll see 3 of the moons, the Galilean moons around Jupiter, but where's the other one? Where's Io? Now, the arrow that I'm showing there, you can see that's offset. It's almost a full planet width away from Jupiter, off to the left, or that would be the east direction. So if you were watching this 1 second or 2 seconds later, you get that. Io pops. Do you know what happened? So do you know what type of event this is called? This is an eclipse event that's happening. So if a planet goes in front of, that's a transit. If it goes behind the Jupiter planet, that's an occultation from our perspective. But what's happening here is that Io was in eclipse. I don't know if you can imagine it here, but let's say the sun's over here. It's obviously a lot further away. So the sunlight's going this way, and Jupiter is punching a hole behind it. This huge hole, this huge black shadow cone is in there, and Io is just doing its thing. It's going counterclockwise again, orbiting around Jupiter, and it's in the shadow, and then it pops out of the shadow, and then it's being exposed to full sunlight. So that's a neat event to look for, that Io is not there, and then suddenly it's there. So that's one of the sort of interesting Jupiter events that you can check out. Spot quiz: which moons of Jupiter are bigger than the Earth's moon? Do you know? All of them except Europa. They're all bigger than our moon. So that's sort of neat to know. Europa is the smallest one, a little bit smaller than our moon. So they're all quite big objects. Jupiter has, I think by last count that I've seen, 79 moons. The rest of them are tiny, they're small. Good luck trying to see them in a telescope. I've been trying for years to see Amalthea and Himalaya, but these are moons that are in the 14, 15 magnitude range. So very, very hard to see those. And the other one's much smaller and dimmer and so on. I wanted to move out beyond our solar system now, and I've focused on just a few constellations here that are on or near the Meridian. The Meridian is an imaginary line that goes from north to south. It goes overhead through the zenith, and objects that are close to that. That means they're as high in the sky as they can be. So I've focused in again on a few constellations that are in this sort of location or area. So there's Pegasus, big huge constellation, and you can see just edges of it at the Pisces down at the bottom left, and Cygnus is up at the top right, and Pegasus is a bit unique in that it's connected to another constellation by the star at the top left-hand corner. It connects to Andromeda. Anyway, here are a bunch of interesting objects that you might consider looking at, or maybe imaging here. And I've got a wide variety of objects, from very simple to complex or challenging. I've got all flavors of objects here. So considering some stars down at the bottom, middle, we have the double star 2958. Those are some colorful double stars and easily seen or split in a small telescope. It's quite lovely at 100 power. On the right edge of that image, you can see there's a star IK Pegasi. If you look at this star, it's nothing special. It's this dim or yellow star, not a lot to sort of look at. But lots of people are paying attention to this star. Some people think it's going to blow up soon. Back in 2016, Dr. Phil Plait described this as a weird star. He says it's a potential outburst star. He also noted that the primary star, it's a two-star system, that the primary, there's nothing special about it that it would explode catastrophically. But it has a white dwarf around it, and that white dwarf is stealing material or accreting material from the primary star, and it's making it unstable. So there's a lot of thinking that the white dwarf may catastrophically burst. It's 150 light years away, so it's not in the danger zone. I think it's around 75 light years. If a star blows up within that distance, it could affect us on Earth in terms of radiation and stuff like that. So that one's okay. But I'm going to periodically watch that star when it's in season, keep an eye on it, see if there's sudden changes in brightness or its appearance. 51 Pegasi to the left of that, kind of in the middle of the constellation. This is a star that has known exoplanets. It's pretty close. It's 50 light years away. It's a sun-like star. It's very similar to ours. In fact, it's notable because it was the first main sequence star found to have an exoplanet. Again, these are nothing to look at in the telescope, but if you're doing a star party and you show somebody that star, you can tell them, we know there are planets around that. So that's always kind of fun fact to share with people. In terms of deep sky objects, if you're working on your Messier certificate down near ENIF, down at the bottom right, you can see we have the globular cluster, or the location highlighted for the globular cluster of Messier 15. If you're working on your RASC finest, NGC objects, up at the top we have NGC 73 31. So that's sort of a neat galaxy. I'll show you an image of that in a moment. If you're working on your Herschel 400s, just down and right of that is a more challenging object, 7217. So a number of galaxies all pretty close here. And your super challenge object is ARP 278. That's two small interacting galaxies that when I looked at them through a 14-inch telescope, I could barely see them. I don't think I was really well dark adapted when I was going for that, but they show up very well in images. And you see the blue line there sort of streaking through the whole constellation. That's the path, or close to the path, of where the comet C2018 W2 Africano will go. Late in September, it's going to clip the corner of Pegasi. This is a fast-moving comet. Right now, it's magnitude 10. So pretty dim. It's expected to brighten up to magnitude 8 or 9. I've seen some descriptions say it's visible in binoculars, but I usually don't get real excited by those kinds of numbers. Anyway, check out cometchasing.skyhound.com or arith.net to get more and updated information on comets. There's that galaxy that I was talking about, 7331, that finest NGC. I really pumped up the contrast and brightness here to expose the arms of it. You can see it's very lumpy and clumpy in the arms of that spiral galaxy, so it's pretty neat, but it blew out the core. But do you notice to the left? All kinds of little galaxies there. Do you see them all? That's part of the Deerlick group, galaxy group. So there's like 4 or 5 other NGC objects in that. That's very like Stephan's quintet, a whole bunch of galaxies in a very small area. In fact, Stephan's quintet is not far away from this object. So yeah. Yes, I used the Burt Gaffney Observatory, and I was imaging all the RASC finest NGCs, so that was one of the targets. Yeah. And I also imaged this ARP object. There's those two interacting galaxies. So you can see they're pretty small compared to that other galaxy, but clearly they're distorted, they're bent. There's something going on gravitationally with those. But that I could barely see visually in a 14-inch instrument. But that's NGC 7253A and 7253B. Again, a more challenging object there. So I wanted to feature now a few little constellations. Maybe these don't get a lot of attention. Everybody's going for things in Cygnus or Aquarius and stuff like that, which you can see just at the edges of our frame. But there's a bunch of little tiny constellations here, some with really silly figures like Vulpecula up at the top, just that stick. those 2 stars highlighted, that's kind of strange. But Sagitta always looks like an arrow to me, and the Delphinus is always a really evocative sort of shape. Down at the bottom left there, that little sort of quadrangle thing there, that's Equuleus. The little horse constellation, I don't know how you get a horse out of that, but it is what it is. But lots of neat objects in here for your consideration. You can see the Milky Way is running through the background. Again, I've got some double stars like Struve 2737 in the little horse. Another double star in the middle at the neck of the dolphin, Beta Delphini, or Rotanev. That's a neat double star system. And Answer up at the top is a double star in Vulpecula, on the right edge of a Vulpecula there, and use your binoculars for that. It's a super wide double star. And while you've got your binoculars, pan down a little bit and you can see the coat hanger. So that's a very nice sort of object at low power. I don't know if you've seen the coat hanger naked eye. That can be done too if you've got reasonably dark skies and you have a really good eyesight or a good prescription. You might be able to tag that. There's a couple of Messier objects here. We have the dumbbell in Vulpecula. It's a big planetary nebula. That's cool to look at. Here it's colorful in images. We have the globular cluster M71. I'm kind of in the middle of the arrow. And that that might give you the impression from the alignment that it's on the far side of the galaxy. Most globular clusters, I always think of them as like bees around the hive of a galaxy. Most globular clusters are out in the halo. They're out in this big spherical shape around a disk, a galaxy. But M71 is right in the plane of our galaxy, and it's relatively close. I have a finest NGC in here again, and a Herschel 400 object, so you can see there's a couple of NGC targets there for your consideration as well. Again, these are all on the observing list that I made for you. There's an image. Again, I did this with the Burt Gaffney Observatory, and I still struggle with processing here, but I used the red, green, blue channels here and put them together, and I was quite pleased with this result. I saturated it a little bit in terms of the color, but you get a neat sort of range of colors here with these stars. That really bright one, that's that binocular double star with the companion way up to the top there. And in the image, they look kind of golden blue to me, maybe. But in my log notes, I wrote they were both kind of gold colored. So that's sort of interesting. But I shot this image for that teeny weeny little double star that's in the kind of in the middle, just below center. I was imaging that star. That's the prosaic PAU 3855. But there's a yellow star there and kind of an orangey one to the right. And then I wrote in my notes, the bottom left one, it looked kind of purple. You can't get purple in star colors, but that was my impression. But I love all these other stars nearby, all these different sort of colors for those. So that's sort of neat. I remind you that you too can use the PGO Observatory in St. Mary's at St. Mary's University in Halifax for free using social media interfaces and so on, like I've done here. If we turn north now and look at Cepheus, this is a constellation that's on the Meridian, but rising up high. It's not down below Polaris or below the North Celestial Pole for the bulk of the evening. And I've got some easy naked eye or unaided eye objects here for your consideration. Down at the bottom left, or bottom right, excuse me, of the screen, but at the point of this constellation, there's a famous star here, Delta Cepheus. So that's a variable star, and it changes quite frequently. I think the rate is around 5.4 days that it changes in brightness, and it varies between the brightness of the nearby Zeta star and the nearby Epsilon star. So it's really easy to gauge the brightness of this. You don't need any equipment. You can look at this with just your eyes. Ian Wheelband taught me how to do this. So is it as bright as Zeta? Is it as bright as Epsilon, or is it in between? And carefully note the date and time in your logbook, and you've been, there you go. You're doing variable star observation. The Garnet star to the right is also a variable star. It has a 2-year period, and it changes quite a lot in its brightness. The Garnet star is a popular target, is in a lot of lists described as a red star. Whenever I've looked at it, I've never thought it terribly red. I've seen other ones that are a much deeper sort of color, but it is still a colorful star, quite a good stark orange color that you'll see. But look at red stars in as low power as you can. You should be able to see that naked eye when it's bright, or use binoculars or super low power on your telescope to draw in other nearby stars for better color comparison. I've got a double star that's quite attractive, way up near the top, Struve 2657 for your consideration. But at the right-hand side of the image, you'll see a funny looking thing here. This is the Cygnus constellation down at the bottom right here, and there's a little finger sticking up from that. I don't know why they did this, except I think they just wanted to keep or enclose an object in Cygnus formally here when the IAU set up these patterns. But there's two objects side by side here. 6946, that was the first slide in my presentation here. That's the fireworks galaxy. So So that object is there, and then nearby is 6939, which is a big, loose, open cluster. So two objects, two in the view if you're using low power. Here you can enjoy these objects. I did a super wide field shot many years ago, piggybacked with my camera on a large telescope. Do you see them? See the two objects there? So there's that fireworks galaxy. The fireworks galaxy is listed in the Observer's Handbook as one of the 40 brightest galaxies. I don't think it's that bright. It's got really low surface brightness there. But it is what it is. That's the fireworks galaxy at the top, and then you can see that open cluster, which is arguably a bit bigger in terms of dimension or size than the galaxy. But that's neat. Two in the view there. So moving on now, in terms of space flight, there's a number of interesting activities going on. The James Webb Space Telescope has been recently integrated, the two main components, and now it's going through more testing, more shake testing and shake and bake, stuff like that. The Japanese Space Agency was to launch one of their cargo craft, the HTV, up to the International Space Station. I actually caught it. I thought it was a couple of days from now, but they tried to launch yesterday, but they scrubbed. They had a fire on the unexplained fire on the launch pad, so they've pushed off to a future date. I haven't heard when that's going to be yet, so that date is wrong. It's not the 12th there. Boeing is working on their Starliner spacecraft. This is going to be human-rated. It's going to be one of the companies in the United States that's going to carry astronauts to the International Space Station and beyond. So presumably they're getting ready to do some testing of the Starliner, but I don't have any confirmed dates for that right now. Flyovers of the ISS, the space station again, in the evening times, those start up again on Tuesday the 17th of September. So you might check those out, and I've noted on my little calendar here for your reference that there's a couple of super bright passes on October 5th and 6th. And remember, October 5th again is when there's stuff going on with the moon. So lots to look at that evening. There's a Soyuz crew or crew in a Soyuz craft launching in later September on the 25th. And I'm going to try to watch around this launch very closely. When the space shuttle was going up to the space station, there were a couple of times where you could get, it was flying over Ontario, and you'd get a dual flyover. You'd get the ISS, and then ahead of it or behind it, you get the shuttle. So I've been trying to get dual flyovers to see two spacecraft at the same time when they're docking or undocking. So maybe there's a chance to do that. The Soyuz is super small. I don't know if it's going to be really easy to see. Some anniversaries. The Alouette 1 satellite was launched. That's Canada's first satellite. That was launched back in 1962 at the end of September. And NASA's birthday is coming up soon, October 1st, many years ago. And perhaps what started it all, the Sputnik, was launched on October 4th in 1957. So some neat sort of anniversaries there. So just to wrap up here quickly, there's lots of things going on with Jupiter. Again, keep an eye on my calendar for multiple events. The moon Io popping on the 28th. Just before that, there's, again, several things happening at the same time. Great red spot, transit of a moon, and then the shadow transit of that moon on Friday the 27th. So lots to look at there. And on the 3rd of October, Jupiter's really close to the moon. And you might be able to see that in the daylight. That's always sort of fun, spotting planets in the daylight. So use the moon as a guide to help you do that. Saturn is still amazing. The rings are still very well canted for us, so lots to look at there. Triton, I didn't mention it in a detailed slide, but Triton, we saw that is in opposition, so it's close to the Triton, the moon around Neptune, is close to opposition, so that means it's very, very easy to see the moon. Triton is also bigger than our moon by 1,000 kilometers or so. So amazingly, even though Triton is, or Neptune, excuse me, is really far away, 29 astronomical units, the Earth-Sun distance, it's very, very far away, and the planet itself is nothing to really look at, no detail on that other than a blue disk. You can still see the moon Triton around that. But look at elongation times when the moon is as far away from the planet as possible. That makes it easier to see that. And they're on my webpage article. I show you a tool that you can use to figure out those best times. Again, lots of stuff going on with the moon, and Saturn's nearby on the 5th. Comet Africano again is moving southward very, very rapidly, so look for it when it's still quite high in the sky, like up in Pegasus, if you can. And if you like those long nights, then you can start to enjoy those on the 23rd of September, and maybe let's try for observing or imaging a dual flyover on the 25th, or maybe a bit before, a bit after that. So I think that's it. If you take a picture of that QR code or scan it with your phone, that'll take you directly into my article at the RASC website here, or you can simply type in that URL that I'm noting. The TSTM 1909 is the specific page, or just search in our website for that. And again, I've got the calendar and the various files that you can download for your reference. And to toot my own horn, if you go to my blog, there's lots of information there and stuff about software and planing and things like that. So I think that's it. As usual, I've run long here, but is there time for questions? Of course. Okay. So there's a microphone. Chris, hi.
Looking a little farther ahead, I'm not sure if it's in your period you covered or not, but I've been prepping my calendar for October for space.com. I saw a couple double shadow transit dates for Jupiter coming up in October, so that's something to watch for as well.
Yeah. So I really like a single shadow on Jupiter is amazing, and some of the close-up moons like Io make very stark shadows. Some of the more distant moons like Callisto, those can be harder. They're softer shadows, harder to see. But when you get two shadows at the same time, well, you gotta make a special trip for those sort of occasions. Yeah.
Okay. Any more questions? Good.
Okay. Thanks again for your time.